Good morning. This is your stats sensei, Mr. Spensei, and we're going to do a warm up on a hypothesis test. The hypothesis test has actually been run for us, and we're only going to do parts of it. Mainly, we're going to do the write the parameter, the conditions, and then the conclusion because it's already been performed. So let's look at the scenario. A sociologist was investigating the ages of grandparents of high school students. The sociologist collected data on the current ages and years of the students' maternal grandparents by taking a random sample of 10 high school students. All right. So we have a sample of 10 out of 1,163. That's going to be important as well because that's our population size. The difference in the ages follows a normal distribution. Okay, that's important because our sample size is less than 10, less than 30. Here's the data. Here's the data. So we have the age of the grandmother, the age of the grandfather, and then we have the differences. Okay, so 75 minus 74 gave us 1. So obviously we went grandmother minus grandfather. All right, and let's go ahead and note that down because we're going to need to know that. Grandmother minus grandfather. Okay, and that's what's been noted here. All right, so directions, write the parameter, the conditions, and the conclusion for the scenario. Because here we have the hypothesis given. No, there's no difference in the ages, and mu d minus the grandmother minus grandfather is less than 0, indicating the grandmother was younger. Because we have a 76-year-old grandmother and a 78-year-old grandfather to indicate that's what we're testing. So less than. All right, these are our statistics. So the first thing we're going to do is it says write the parameter. So let mu d equal the true population mean of the differences in ages, and we need to put the order grandmother minus grandfather. Okay, that takes care of that. Then we need to do our conditions. The first condition is random sample. Well, we need to go back and check. Was it a random sample? So let's go up there and take a look. All right. It said random sample. That's good. Of 10. Well, I see lots of data points, but there's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs. So the number of pairs, not the number of points. So we have random sample of 10, and that was given. All right. The next one, differences are independent. And if it's a random sample, we can go ahead and claim that. Number 3, or the third one, we need to check the n is less than 10%. Well, we have n equals 10, and then we always have to multiply by 10, and that equals 100, and that needs to be less than our population. Well, our population was 1,163, so it is less. So that's met. And then normality. Well, we need a sample size of 30 or more. Well, we only have it of 10. But fortunately, they told us the differences follow a normal distribution. So we're going to write differences are normal. And that was given. So we can go ahead and put a check mark by that. Lastly, we need to write our conclusion. So we're going to have to refer back to our information. And up here we have a p-value of 0.2465, which is pretty large. 0.2465, and they told us our alpha was 0.05. This is greater, so we're going to fail to reject, so that's going to be our decision. So based on that information. So our p-value is 0.2465. Our decision, we fail to reject the null. There is sufficient. In other words, there's plenty, there's enough, there's sufficient evidence at our level of significance, or our alpha level. So at alpha equal 0.05 to suggest that and we need to restate our parameter, true population mean of the differences in ages, that the true population mean of the differences in ages. And then we need to put the order. Grandmother minus grandfather is, and now I need to go look at the alternative. Well, what was our alternative? Well, that's a less than sign. So is less than 0. All right. And we fail to reject there is sufficient. Oops, that's wrong. There is not sufficient. So make sure that you always put the not in there. I did that on purpose to emphasize it. So there is not sufficient evidence. All right. And when we say there's not sufficient evidence, we could come back, and although that takes care of our conclusion, we can say there is no difference in age, no significant difference in age. At the 5% level. All right. So there's no significant difference in age. Significant difference in age at the 5% level. Certainly appreciate you watching and hope to see you on the next one.